Welcome back to another video. Dr. Tarcia Huber here, and today in this video we are going to be talking about trigonometric form of complex numbers. Alrighty, so back in college algebra we talked about complex numbers, or you learned about complex numbers in college algebra. Those are numbers in the form a plus bi, where we call a the real part and b the imaginary part. Alrighty, so this right here is called the rectangular form of a complex number. We call that the rectangular form, and we cannot order complex numbers. So just like you could put regular numbers in order, we can't order complex numbers, but what we can do is we can graph them, and we can use the graph of them to organize them. Okay, so we organize them using vectors, and we graph them in a coordinate system, or what looks like a coordinate system. However, instead of this being the x-axis, we now call this the real axis. And instead of this being the y-axis, we now call this the imaginary axis. And so now if we wanted to graph the complex number, say 3 minus 2i, then we would go to 3 on the real axis, and we would go to negative 2 on the imaginary axis. So here's 3, here's negative 2, and we'll put a point right there. So that's like our normal 3, negative 2 ordered pair. Except instead of just leaving a point there, what we do is we draw a vector with the initial point at the origin and the terminal point at that point, 3, negative 2. So our vector 3, negative 2i, or our complex number 3, negative 2i would look like that, graphed as a vector. Okay, that was fairly straightforward, right? So I want you to try this. I want you to see if you can graph the complex number 1 plus 3i. Pause the video for a moment. So to graph 1 plus 3i, you will go to 1 on the real axis and 3 on the imaginary axis and put a point right there. And then you'll draw a vector from the origin to that point. So 1 plus 3i should look something like this. Draw a line from the origin to that point. And there is your vector, and that is the imaginary number, the graph of the imaginary 1 plus 3i. So just like we can graph an imaginary number, we can graph the resultant vector of two imaginary numbers, or two complex numbers being added together. And so for this first example, we want to find the sum of 6 minus 2i and negative 4 minus 3i. So 6 minus 2i plus negative 4 minus 3i. Remember, to add those, you would add the real parts together. So we would add the 6 plus negative 4 together. And we would add the imaginary parts together. The negative 2i minus 3i. And we would get 6 plus negative 4, which is 2. Negative 2i plus negative 3i is negative 5i. So that's how you add those. We added those in a previous video. But now what we want to do is we want to graph both the imaginary numbers, each individual complex number, but we also want to graph the resultant vector, or the sum of those two. So the first thing I want to do is I want to graph the 6 minus 2i. So I'm going to go to 6, 1, 2, 3, 4, 5, 6, and I'm going to go down to negative 2. So here is my first vector. That's 6 minus 2i. Then I want to graph negative 4 minus 3i. So I'll go to negative 4 on the real axis and negative 3 on the imaginary axis. And so here will be that vector. Then I would graph the resultant vector, which is 2 minus 5i. So I will go to 2, which is here, and then down to negative 5, 1, 2, 3, 4, 5. So 2, negative 5 will be here, and here is the resultant vector. That's the 2 minus 5i vector. This one was the negative 4 minus 3i vector. And so if you remember, to find the sum of two vectors, it's the corner of that parallelogram. So that happens at the corner of the parallelogram that's formed by completing that, or making parallel sides to each of those individual vectors. So you can actually see it now once you graph it with the complex numbers. Okay, so that's how you would add those two complex numbers, and then graph each complex number and graph the resultant vector.
Okay, I lost my sound quality in my video, so I have to switch over to another method of recording. So we will see how this screen recording goes. Okay, so now we want to actually talk about how do you get to the trigonometric form of a complex number. And so what I have here is a standard vector x plus yi for the complex number that's in general x plus yi. And this is r. Remember, r is the magnitude or the length of the vector. And this is theta, which is our direction angle. Okay. And so what we want to do is we want to consider this angle theta, and we want to calculate the cosine of theta. So remember the formula: cosine of theta is equal to the adjacent side, which would be x over r. And then if we do the sine of theta is equal to the opposite side over the hypotenuse, which is y over r. Now, if I solve both of these for the x and for the y, I end up multiplying both sides by r. And that's in both cases. So I would get that. I'm just going to write it this way with the x on this side. X is equal to r cosine of theta. And I will also get over here, because the r's will cancel, I will get here y is equal to r sine of theta. And so now what we have is we have a trigonometric form of the x and the y. And so now we want to replace the x and the y with this and our standard complex number. So x is r cosine of theta. Y is r sine of theta. And that's I. So all we did was replace the x with r cosine theta and the y with r sine theta. And then you can pull out a r because both of those have an r in it. And I'm just going to write the I in front of the sine theta. Move it in front so that it don't get confused to being inside with that theta. It's actually not inside with the theta. It's outside of the theta. You take the sine of that angle, and then that's the imaginary part of it. And so this here is the trigonometric form of a complex number. R times cosine of theta plus I sine of theta, where R is the magnitude or the length of that vector, and theta is the argument, or R is the absolute value of the complex number, and theta is the argument of x plus y, the resultant vector. This can also be abbreviated as R CIS theta. CIS is just short for cosine theta plus I sine theta. So it can be abbreviated that way as well. Okay, let's look at an example. We want to express 2 cosine of 300 degrees plus I sine of 300 degrees in rectangular form. Remember, rectangular form is the x plus yi or a plus bi, which we've been used to seeing as well. Either one of those, okay? And so basically, we just need to figure out what is the cosine of 300 degrees. And so in order to figure out what the cosine of 300 degrees is, let's find a coterminal angle to 300 degrees. And so remember, 300 degrees would be here in the fourth quadrant somewhere. So if we find a coterminal angle to that, we would do 360 minus 300, which is equal to 60 degrees. So not a coterminal angle, I mean a reference angle. We need to find a reference angle to 300 degrees, and the reference angle will be 60 degrees, which is this angle right here. That's that reference angle theta prime. That's the 60 degree angle. And what that means is that this 300 degrees is going to share the same x and y values as 60 degrees. It's just going to be different by a sign. And so remember, the cosine of 60 degrees is 1/2. So that means the cosine of 300 will also be 1/2. So I'm going to replace cosine of 300 with 1/2. And because it's in the fourth quadrant, the cosine is positive in fourth quadrant, so it stays positive 1/2. And then the sine of 60 degrees is square root of 3 over 2. And so the sine of 300 will have that same value, except in the fourth quadrant, the y value is negative. So it would be negative square root of 3 over 2. And so you have 2 times all of that. So you're going to distribute that 2 to each of those. So it's going to be 2 times 1/2 plus I times 2 times negative square root of 3 over 2. The 2's will cancel here and leave you with 1. The 2's will cancel here and leave you with I times square root of negative square root of 3. So you would say minus I square root of 3. And that's an I. And so this would be your complex number in rectangular form. And that's how you would do that. So basically you just find the cosine of the angle and the sine of the angle, and you simplify it by distributing the number, the R that's in front of the parentheses, and putting it in your x plus yi form. If you have any questions about that, you can put it in the comments below and I will respond. Alrighty. So whenever you want to convert, so we talked about the rectangular form, we talked about the trigonometric form. So whenever you want to convert from rectangular to trigonometric form, you will have to first calculate R. Well, you will have to first sketch the graph of the complex number, and that's so you can see what quadrant it's in. And then you want to find R by using the formula R equals square root of x squared plus y squared. Then you want to find that directional angle by using the tangent of theta equal y over x with the appropriate quadrant, which is what you find in number 1. And you can find the angle theta by doing the inverse tangent of the y over x. Alright, so let's try this example. We want to write negative square root of 3 plus I in trigonometric form. So the first thing we want to do is just kind of sketch it to see what quadrant it's in. Negative square root of 3 is somewhere between negative 1 and negative 2, so it will be over here somewhere. I'll just say here, negative square root of 3. And then that I, there's no number in front, but there's an understood 1 in front. So the imaginary part will be 1. So your vector would go something like this. It will be in quadrant 2. That's the most important thing, is that we know our vector is in quadrant 2. So then the next thing we will do is find R. R is equal to the square root of x, so negative square root of 3 squared plus y squared, which in this case is 1. There's no number in front of I. Actually, there's an understood 1 there. So negative square root of 3 squared is 3. 1 squared is 1, so you get the square root of 4, which is equal to 2. So your R here is 2, which is the length of that vector. Okay, so then once we find R, we now need to find the angle theta. So we're going to use the fact that tangent of theta is equal to our y over x. Remember, our y is 1. Our x is negative square root of 3. You can plug that in your calculator like that, or you can go ahead and rationalize that denominator by multiplying top and bottom by square root of 3. And you get negative square root of 3 over 3. And one of the advantages of doing it that way is that you should be able to look at that and notice that this is one of our special angles. The angle that gives us the tangent to be square root of 3 over 3. The reference angle for that is 30 degrees. However, it's negative. So first of all, we know that our reference angle is 30 degrees. That's theta prime. And that's because the tangent of 30 is square root of 3 over 3. But since it's negative, that means that's because it's in the second quadrant. We have to figure out what is that angle. So here's our reference angle here. That's the 30 degrees. So to figure out what that angle is, we would do, since it's in the second quadrant, we would do 180 minus 30, which would give us 150 degrees. So our angle theta would be 150 degrees. And so now we can write this in trigonometric form. It would be 2 times the cosine of 150 plus I times the sine of 150. 150 degrees. So that would be that complex number in trigonometric form. So you got to find the R and the theta to be able to do that. If you have any questions about that whatsoever, you can include those in the comments below. All right, one last thing. I want you to try this. I want you to try to write 2 CIS 30 degrees in rectangular form. So go ahead and pause the video for a moment and see what you get. So remember, CIS is short for cosine 30 degrees plus I sine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2. And sine of 30 degrees is 1/2. And so you'll distribute that 2 to both. You get 2 times the square root of 3 over 2 plus I times 2 times 1/2. Well, the 2's cancel here. And that leaves you with square root of 3. You get I times 1, which is I. Is that what you got? Hopefully that is what you got for your answer. If you didn't get that, go back and look and see if you can catch where you made your mistake. And then if you have any questions, then you can still put those in the comments below. But this is our last example that we're going to work in this video. And so hopefully you understand the trigonometric form of a complex number. And if you have any questions, please don't hesitate to ask them. And hopefully this video helped you. And I will see you all in the next video. Thanks for watching.